Okay, so this should be a very quick little exercise because we know how to do the first derivative. We're just going to be doing more derivatives on from that. So if differentiating f of x gives us f dash x, differentiating f dash x is going to give us f double dash of x, and differentiating f double dash of x is going to give us f with a triple dash of x. Every time we differentiate, we give it another dash. Okay, remember that there is another notation, which is if I'm differentiating y, I could use dy over dx to represent the derivative. That is the same as y dash, but sometimes our equations aren't y equals things and we need to be able to use the dA over dr or the dv over dt, lots of other different types of derivatives that we could be doing. If I do a second derivative, it becomes d squared y over dx squared. Okay, so it's the squared is after the d on the top of the fraction, after the x on the bottom of the fraction. And if I do a third derivative, then they just become d3y over dx cubed. Okay, so we're just going to find some higher derivatives. Example number 1 says find the first 5 derivatives of f of x. So the first derivative, f dash x, if it's in f of x notation, I'm going to use the f dash x for my derivative. And I differentiate once. So the first term, the 4 will come down, and I subtract 1 from the power, become a power of 3. The second term times the 3 with the negative 6 to get negative 18. X, subtract 1 from the power, becomes squared. For the third term, the 2 will multiply with the 5 to get 10. X, subtract 1 from the power, will just be an x to the 1, which is just an x. The fourth term is negative x, which would be a negative 1 in front of that x, and the x will disappear and the constant will disappear from the end. That's the first derivative. Let's do it again. So f double dash for second derivative equals, and you do the exact same process but to your first derivative equation. So this time the 3 will times with the 4 to get 12x squared. Second term, bring the 2 down and multiply it with the negative 18 to get negative 36x. Third term is 10x, so I'll take the 10 and the x will disappear and the constant will disappear. So assuming that all the powers are in descending order like that, the last term is going to drop off every time I differentiate it, assuming that there's no gaps in between. So third derivative time. So 3 little dashes equals 2 times 12 makes 24x, power's gone down by 1. The minus 36x, I'll just take the minus 36, x is gone, constant's gone. The fourth derivative works in Roman numerals. I don't have to do 4 dashes, so I'm going to do an IV. So differentiating the 24x, I'm just going to get 24 and the 36 disappears. And finally, the fifth derivative is 0 because I'm differentiating a constant, there's nothing left, it disappears. All right, so there's 5 derivatives. Question 2, to be honest, in advanced, you're never going to go past the second derivative for practical purposes. We're going to be using that to do concavity with our graphs and our stationary points. Okay, but the second derivative is extremely important, so we're going to practice that a bit more in question 2. Find the second derivative of y equals 3x minus 4 in brackets to the power of 5. So this is the function of a function or chain rule. To differentiate that the first time, because it's y equals, I can either use y dash or dy over dx. The power from the bracket comes down to the front, and you multiply that with the derivative of the bracket, which is 3, good. And then the bracket stays the same, don't change the bracket. You subtract 1 from the power, it becomes a power of 4. to tidy it up would become 15. 3x minus 4 to the power of 4. The second derivative, we just do the same process again. The 4 will come down, I'll leave the 15, the 4 will come down the front, it will multiply by the derivative of the bracket, which is 3 again. I'll leave the bracket and subtract another 1 from the power, so we're down to a power of 3. If you multiply all those numbers out the front, 15 times 4 times 3, 180. Okay, so one final question. It says find f double dash of minus 2 if f of x is equal to x to the power of 6 plus 2x cubed minus 13. Okay, so the f double dash means I want to find the second derivative. The minus 2 in here means that I need to sub the x is equal to minus 2 in after I have found the second derivative though. Okay, so let's find our second derivative. F dash x equals, bring the 6 down, subtract 1 from the power. Next term, bring the 3 down and multiply it with the 2, subtract 1 from the power, and the constant will disappear. Second derivative, bring the 5 down and multiply it with the 6, so 30x, subtract 1 from the power. Second term, 2 times 6 is 12, subtract 1 from the power is x. Okay, so I found the second derivative, but I specifically want to know the second derivative when x is equal to negative 2. So I have a final little step here where I sub minus 2 in everywhere where there's an x. So it's 30 times minus 2 to the power of 4 plus 12 times minus 2. Oh, gone ahead of me. Well done. It was a nice, easy lesson today, wasn't it? That's it. That's our lesson today.